Okay, we're ready to get started. Thanks so much for coming out tonight, San Francisco Bitcoin Meetup Group. I just wanted to take a quick moment to thank our sponsors and also Digital Garage, the location, for providing all the food and drinks and the space here tonight. I can get a round of applause. Let's see the Digital Garage people. So just quick about some of our sponsors, Waxman. They're a PR firm over in New York, and they handle a lot of Bitcoin companies and blockchain companies. CoinSource is a great way to get some Bitcoin. They have ATMs all around the country. There's actually, I think, 3 or 4 in the city, just a Bitcoin ATM. And Dash, they've always been a big supporter of our community, and I'm a huge fan of projects that do that. And then, of course, Digital Garage providing the location. But let's not go into too much of that. Let's get started. Before we jump right into the speakers, I did want to do one quick announcement. Buck, if you want to come on up. All right.
All right, thank you. So I work at Purse. For those of you who don't know, Purse is a way that you can buy anything on Amazon with Bitcoin for up to 20 to 30% off in savings. We are, and I'm an engineering lead on the Bitcoin team, which is an open source project that we maintain. We are organizing a hackathon that's going on next weekend. For those of you that are interested, it's called Crypto for Your Thoughts. You can check out our website, c4yt.io. It's going to be, we're expecting about 250 to 300 devs, a total of $25,000 in prizes available, 48 hours, it's free to attend if you register, food, drink for the whole time. It's just, we did one much smaller last year, and it's a lot of fun, a great way to meet people in the space, to learn about the technology. We're expecting people of all levels as well, so if you're looking to just get an introduction to blockchain development, if you're more on the design or BD side, there's also will be opportunities for you to participate. So if you have any questions, just let me know. I've got some cards as well that I can hand out with some info on the website. Otherwise, hope to see you guys there. Thanks.
Thank you. All right, so tonight we talk about microtransactions. We have 2 speakers that are dealing with this in their project right now, and they're each going to do a short presentation, and then afterwards we'll do a joint Q&A. So if you have any question ideas throughout it, write them down, keep them in mind, and we'll pass the microphone around at the end. So let's get started. I want to go ahead and introduce up Jihan Trebek, and he's going to be our first speaker.
Thank you. All right, so I'm going to give you a very quick overview of payment channels. And payment channels are a microtransaction technique. And they're not the only one, but they're one of the most well-researched options. I'm CEO of Althea, and what we do is we make routers that can pay each other for bandwidth, so that people can set up networking equipment in their cities and create a decentralized ISP. And they pay each other basically per byte every 5 seconds. So they need to be able to pay each other very, very quickly. And that's so that if you're receiving bandwidth from another device, you're paying for it. If you're not, you're not. You don't have to give them money ahead of time or anything like that. So that's what we use payment channels for. But this here is actually a very high-level overview of payment channels. And I'm using, I'm just going to go over these diagrams with Alice and Bob. And I've got here in the middle bank or blockchain, and that's just to emphasize that payment channels are kind of a general purpose thing. You could use payment channels with a conventional payment processor. They don't have too much to do with blockchain other than the fact that they're very useful because blockchains are very slow. So, and also, they're built to work with kind of cryptographic payment code and stuff, so it's a natural fit, but it could be done with a bank too, which is interesting. So, how it works basically is a payment channel is kind of like a tab that you can keep updated with. With someone else, and so each of the participants needs to put some money into the channel. So in this case, Alice and Bob are both putting $100 into the channel, and that's called opening the channel. And so while the channel is open, Alice and Bob can send each other certain amounts within that $100. So Alice can't send more than $100 to Bob. Bob can't send more than $100 to Alice. And also you could have it so that, let's say Alice knows that she's going to be the only one sending money to Bob, not the other way around. You could do it so that Bob doesn't put any money in. And so what it is basically, you put money in the channel, and then you give the counterparty, you keep giving them transactions that allow them to unlock more and more of that money. So, so what's happening here is that Alice and Bob have both put $100 into escrow. So that's either on the blockchain, the smart contract, or with the bank, and they have an agreement they've made with this bank or blockchain, which basically says, return these deposits to Alice and Bob according to the updated amounts in a note you will receive from one of them. The note must be signed by both Alice and Bob. So it's basically, if they both say, so that's when that bank or blockchain receives that note, that channel will be closed. And so they're saying, hey, Alice and Bob sent back and forth this amount of money, but the ending balance is this, and so you close it out and they get their money. So during let's see, so as we go over this here, so this is where Alice is sending Bob. So Alice wants to send Bob some money, and this is kind of the agreement that's in place. Alice wants to send Bob $5. So she writes a note that says that she has $95 in the channel now, and Bob has $105. So it's still a total of $200 because they both put $100 in, but Alice is $5 poorer and Bob is $5 richer. So Bob receives this note that's signed by Alice. Bob knows that he could take this note and he could take it to the bank or blockchain and he could unlock he could close the channel and basically get his $5 off. So Alice has sent Bob this note and she has paid him. And so that's something that you can't do with anything, with any other electronic payment method. That's something you can do with cash. If I can hand you some cash and pay you, but if I want to pay with a credit card, I have to send a message to a bank, which is going to update your balances. With payment channels, I can hand you a signed note and pay you with that note, and that's what's so powerful about it. So you can basically make payments as quickly as two machines can send packets back and forth to one another. No third party has to be involved in the payment process. So yeah, so you see Bob's, also another thing to notice is Bob's signature is blank. This is where Alice has signed and sent to him. And so this is he can sign if he wants to. And then usually in actual implementations, he'll sign it and send it back to her so that she has the, so to update the record and stuff, they're both cooperating. Another thing to know is that channels, they really operate on a principle of cooperation. So the idea with the channel is always that the blockchain is kind of like the judge. The blockchain is kind of arbitrating the cooperation between Alice and Bob, because each of them know that at any point in time they can close the channel and get their money out. So that's the basic principle. There's some more advanced channel things that also use I won't get into that, but where you have arbitrary logic that people know is going to get run on the blockchain. We'll keep it simple for now. So actually this diagram right here, that's what I was just explaining to you. So that's just the visual representation of that. Bob has submitted that note to the blockchain, has closed the channel, has gotten his money out. Here's an issue. So Bob could cheat, and I'm going to go over another important aspect of channels which prevent this kind of cheating, but let's just say they didn't have this. So Alice and Bob have sent payments back and forth for a long time, and Bob is submitting this closing transaction, and that's from back when they first started the channel months ago. What it really is now is that Bob has 0 and Alice has 200, and that's what they agreed on. But if Bob's able to just submit this transaction, close out the channel and get the money, then Alice is out of luck. So the way you combat that is you do two things. You put a sequence number on every update. So if Bob is signing an update that he's going to check that the sequence number is 1 or more higher than the last update that was signed by both of them, and so neither are going to sign it with the wrong sequence number, of course. And so when the blockchain gets that, the blockchain is going to know, it's going to be able to tell between two updates which one is the latest. The other thing you do is add a hold period. And so this means that the blockchain is not going to let that money out until the hold period is over. So let's say 2 days. And so if Bob comes in and he submits this old update, there's going to be a period of 2 days when Alice can kind of challenge this. And so let's say the sequence number here is at 1, Bob submitted it, and the real sequence number that Bob and Alice have agreed on between themselves is like actually 100, right? And it says that Bob has $0 because Bob paid all his money to Alice. So during those 2 days, if Alice is watching the blockchain, she can see that Bob has submitted this old transaction, and she can see that happen, and she can submit the newer one with a sequence number of 100. The blockchain is going to accept the newer one, and that way Alice can stop Bob from cheating. So you can have this payment mechanism where payments are very fast, very scalable. They only go between these two people. And then both participants know that if they check the blockchain once every hold period, they can be sure that the other is not going to try to cheat them. So one risk that exists with the hold period, this introduces a different kind of counterparty risk, is that if Bob wants to close, so if one of them wants to close the channel, then and the other doesn't agree with closing the channel, the money can be locked up in the channel for 2 days. So maybe they could have gotten interest payments on that money in 2 days, but they can't close the channel. So that's the risk, is that the money stays locked up. And oh yeah, sorry, I should have scrolled faster. Here's the newer update of sequence number 2 is overriding the old one, and that's the one that's considered valid because the sequence number is higher, and it's signed by both of them. So what if you want to close? Both of them agree. They are not, they're full agreement about who's supposed to get the money and all that stuff, and they want to close the channel immediately because they don't want their money to be locked up anymore. So they can set the hold period to none, and with the hold period of none, the blockchain lets the money out immediately. But of course, the note that says the hold period is none has to be signed by both of them, and if they're not cooperating, so if one of them disappears or they have some kind of dispute or whatever it is, then the risk is that the other one's going to have their money locked up for however long the hold period is. So this is a way though, in the overwhelming majority of cases, if people are not trying to, trying to cheat the channel system is futile because it's not going to work. But as long as they're cooperating, it's going to be a hold period of none, and so it's not, they don't have to worry about the money being locked up. So this is where it gets more complicated. I'm going to go into multi-hop channels, and so that's Lightning actually was recently released. I'm not sure if it's on the main net of Bitcoin. Yeah, nice. So that's a pretty big milestone. And Lightning implements multi-hop payment channels, and it uses something called hash locks. Now, what I'm going to show you here is not the exact way that Lightning does it. Lightning does things in kind of a complicated way because of Bitcoin script. People might dispute that and stuff, but it's a little bit, it's not quite as pure of an abstraction I'm going to show you here. They do a bunch of stuff because of how Bitcoin works. But this is kind of the idea behind it. So basically, let's say that Alice wants to pay Charlie, and Alice does not have a payment channel open with Charlie. So if Alice were to have a payment channel open with Charlie, that means that she would have had to put this money in escrow with Charlie to be able to pay him in the future, and maybe she just hasn't done that yet. So with hash locks, with multi-hop payment channels that use something called hash locks, she is able to pay Charlie if she has a payment channel open with somebody who has a payment channel open with Charlie. And so let's say that person is Bob. So a hash lock depends on, there are other ways to do it too without hashes. Actually, you can do it with signatures as well if you want, but the simplest case is it depends on a hashing algorithm. Hashing algorithm, just to go over really quick, is like you put in some string and you get out what looks like a random sequence of letters. Looks like a complete, and it's also a predetermined, it's like fixed length, it's just a random sequence of numbers. You put a different word in, it's most likely going to be a different random sequence of numbers, actually overwhelmingly likely to be a different sequence of numbers. The important thing is that every time you put a word in, you're going to get the same sequence of letters and numbers out, and from that sequence of letters and numbers, which is called the hash, you cannot compute what word you put in. That word is called the preimage. So the way you use this to enable multi-hop payment channels is that what Alice does is she makes a payment to Bob, and this payment has this kind of special exception in it. It says that Bob can't get this this money out. So let's say, what is it here? It's a payment of looks like $20. So Bob can't get this money out if unless he can show the preimage to he can show the preimage to this hash. So let's say the hash is XYZ123. Alice sends the preimage, like in this example, it's the string secret, which happens to hash into XYZ123. She sends that secret to Charlie. And so now Charlie has the secret with which Bob can unlock his money. So now if Bob wants to get that secret, to get his money from Alice, he has to make another payment that's locked with that same hash to Charlie. And he does this without having to know what the secret is, of course. And so now if Charlie wants to get his money out, the sort of the end game scenario, if everyone were to close their channels, if Charlie were to say, hey, I'm done with this channel thing, I'm going to close it, without cooperating with Bob, Charlie would have the secret, and so he would be able to get the money out of the payment, the locked payment from Bob to Charlie. He'd be able to get that money. And so what he can do is show Bob, so in most cases he doesn't want to close the channel, because they're still using it. So what he can do is show Bob the secret and say, hey, I could close this channel and get this money, so you might as well update the channel with another transaction that says I already have this money. Because he can prove to Bob that he would be able to get the money if the channel were to be closed. So in proving that, he has to reveal the secret to Bob. And Bob hashes it and he checks that it matches XY123. And so Charlie's revealed the secret. Bob can do the same thing with Alice. And then Alice makes another transaction updating Bob. I mean, there are also other workflows to make that kind of thing happen, but this is a simpler one. And similarly, if Charlie were, let's say he did close the channel, this is his last transaction, close the channel. He closed the channel, he still has to post the secret to the blockchain. And he posted to the blockchain, and now Bob can see it on the blockchain. He can get his money out from the hash lock payment from Alice. And so this is a way that Alice doesn't need to give Bob money and trust that Bob's going to give it to Charlie. She can make it so that Bob is not going to get that money until he has given it to Charlie. And that's what's really cool about hash locks. That's also, I believe that's the big innovation that Lightning brought into the equation. I don't know if anyone did it before Lightning. There were channels on Bitcoin since maybe 2011 or so. But this is the hash lock is pretty exciting. So yeah, that's a hash lock. Yeah, that's what I should have shown you when I was explaining that. I don't know if I have any more diagrams. I guess my time is not quite up. Well, I guess it's kind of up. So if you have any questions, or we can move on to the next one, or no.
A quick question, just one.
I'm curious to hear more about your project and how you're using.
We can save it to the end, I guess.
Yeah, let's do that. Let's move on to Christian, and we'll do all the questions at the end. Right. Who's ready to vote on Christian?
Thanks, Jim. So we're welcome up Christian. We'll get him set up really quick, and we'll go from there.
There you go. Yeah, just look. That's fine. Do you have a if you could choose over
Somebody wants to grab a drink, we're just going to restart his computer and we'll go from there.
Yeah, that's fine. Because it's not working.
Sorry, I didn't catch your name. What's your name? John. From Cisco.
Oh, cool.
So you guys are actually making it out?
Yeah.
Pretty cool.
I mean, we're not making hardware stuff.
Yeah. That's pretty cool. I can see put that in pictures.
Absolutely.
Do you have a card?
I don't have a card with me. We can talk more a little bit. That guy was asking about it, so I was just feeling out.
Cool. Yeah. Good stuff.
And then just send it, share it to my
big cluster. So basically, CJDNS.
you share it.
20 of the actually. That was kind of a big thing.
Oh man, because like I had so many friends, no, because I had like 2 friends that were doing like that side and then like my new server took one. And that's how I'm working on routing works now. But those friends still took it out. And like I'm ignoring working on accounting software. I want to use dinner and some civil and global and I don't know, I should say that.
Hi, hello. I'm Christian. I work in video games. We have a company called Migo, and about 3 years ago we decided we were gonna focus on cryptocurrency. we've been making a game called Hammercoin for a while, and this is a small talk about microtransactions and where we are now and how did we get here. So it's difficult to define microtransactions, right? Because what is a microtransaction? Is a transaction less than $1? There's no hard definition of a microtransaction. But according to this guy, maybe a microtransaction is something that is not for life and death type of shit. So this is something that we think about a lot, especially when we started seeing the big amount of transactions that happened during the last year and how the mempool was being filled up. And our games that relied on very small fee payments were not viable anymore. So, but microtransactions in games is not something that the cryptocurrency world is bringing to video games. Microtransactions in games are happening, and they're happening a lot. If you think about it, this only one company has made 4 billion in microtransactions in 1 year. So if we define microtransactions in something smaller than $1, that's a lot of microtransactions. Especially a lot larger than the Bitcoin is capable. If this is not new, what is Bitcoin bringing to video games? Because the system is already working, it's much bigger, and how game companies are going to move to Bitcoin or cryptocurrency if things are doing so well? Well, the thing to understand is the type of microtransaction that the cryptocurrency world is bringing to the games. It is a conceptual difference, and it's a different type of microtransaction. So this is the type of microtransaction there is now. The developer is at the center of the game, and every player is sending their microtransaction to the developer, to the owner of the game. So this is the type of relationship, this is the type of microtransaction we can do with credit card money. And this is not the microtransaction we want to see. I want to explain what we want to see in the future and what we think is where we are going. For example, in Patreon, there is a gaming community that asks for money to maintain a Minecraft server because it is a little expensive. It is an expensive hobby to maintain Minecraft server, and the Patreon community is open for people who are hosting servers to ask for money from their players. The players are happy to pay a fellow player to maintain the server and to be a moderator. In Roblox, and this is a game that is similar to Minecraft, but a high school kid will tell you that it's the new Minecraft. But in Roblox, there is a Robux. There is a currency inside the game that mod developers can earn by creating mini games inside. And these are also players of the game. They're not the developers, they're not the owners of the brand. They are the community, right? And in Twitch, the most talented and funny players, the guys who everybody loves to see and watch playing, they ask for money, and people are happy to send them their money if they give a shout out or if just to support them because they like watching them. And this is happening every day. This is something new. This is something very different, and is changing the microtransaction world from this to this. A place where transactions doesn't happen between only the player to developer. It also can happen player to player. So I think to go back, let's go back to our first slide, the life and death type of shit. So okay, yeah, maybe video games are not the use case for a cryptocurrency. Maybe a game is not the use case for the blockchain. But this is changing with the payment channels and state channels, which mean that cryptocurrency and the blockchain can be used to authenticate players and give them a way to participate outside the blockchain. But the most important thing is that players can be part of the community. The players can take part in the success of a game. Now, if you make a successful game in the future, you will have to think about, like Roblox is thinking about, like how can we share our success with the community, because the community is also making the game. So this is the new way of thinking, and it is up to us, the people who work in Bitcoin, people who work in cryptocurrency, to be open-minded and to include everyone, even if it's not life or death. Because this is also something very important for some people. Maybe there are some people that are not lucky enough to live in a wonderful city like San Francisco, and video games are a place where they go to feel great. Video games are a place for many people to express themselves. Video games are places that fill the lives of many of us. So maybe it's not life or death, but it's important. And there's thanks to Lightning Network type of technologies and the new state channel technologies, there is room for video games, or there will be room as the technology is getting more mature. So we are very optimistic about this, and it depends on the game developers and game communities to embrace this technology. Otherwise, there will be many coins, closed gardens, like what Twitch is doing, like there's going to be microtransactions, 4 billion of microtransactions happening on a authoritative model, or something that cannot allow players to express themselves, that treat players as a customer and not as a part of the community, not as a citizen of a virtual world. So I'm very happy, very optimistic about the new technology for microtransactions that can happen with layer 2 solutions. And we are working on implementing that as soon as possible. We will see in the future how we contribute to make this more popular, because we are already having trouble explaining to people how to use regular Bitcoin, and the next challenge is how to explain players to use the Lightning Network or more complicated stuff. And I think that's a challenge for not just for us, but we have to convince other game developers to do the same. And that's what we are trying to do at the moment. And yeah, so I'm happy to, after this, to answer all your questions about payment channels and stuff. And video games, of course. Thank you.
We got a question for you. Why don't you come up, Gio, and you can ask your mic.
I was wondering, actually, I don't play too many games. I play a game with these airplanes that fly around and shoot each other, but that doesn't have any any currencies. But my understanding is that in a lot of games, the gaming company manipulates the currency to make the game more fun by issuing it to people for different things and stuff. With a cryptocurrency where it's actually worth some money, it seems like it would make it harder for them to do that, right?
Yeah, and I think that's the point. If you make a crypto game that has a smart contract, where the smart contract defines the rules, you are having transparency to the users. Because if you upload the rules to blockchain, you cannot change the rules. And this is something that is very critical for certain type of games, like card games, trading card games, for example. Because you can have a rare card, right? And then on a whim, the developer decides to print that card a lot of times, and then it's not rare anymore. So if you have a smart contract that right away defines how much the distribution or some basic rules, there can be some transparency. And I think this is the frustration of players not knowing what's behind the black box they are investing their time in. You can see on the debate, if you follow the debate if loot boxes are gambling. So I think people are realizing that the video game company can be very evil and manipulative, and people in the future will prefer a game that has clear rules. And if you see the card games that work on Ethereum or CryptoKitties, they have a totally different relationship with players, and a much more transparent one. And I think this is just the beginning, and we need to make aware all the players of this.
Let's go to the audience for questions. If you raise your hand, the microphone will come around to you.
I was just wondering if we're seeing anything like similar to like an RPG or something with like rare items and things that are currently being developed. CryptoKitties are sort of like these rare cats, like they're worth so much for this reason because they're rare. But is there like any with like RPG elements and such that are like find rare items, trade them, put them on auction houses, things like that people are currently developing?
There are a few projects of non-fungible token exchange and Dutch auction types of these non-fungible tokens. So, and this is very cool. We are actually developing a game that works with crypto objects. And the cool thing is that the exchange can be outside our game. So it's not only about if you're free to trade your game object that you can with something that you bought with credit card. You can trade a crypto object that you bought with crypto because of credit card compliance. But it's not just about that you can, it's that you can do it outside the game. So that outside the developer systems. And the object can exist even if the developer systems are offline. So that is that is a change of concept, that is a change of paradigm for the gaming industry that is used to having control of all the items without any consideration for the player. I don't know if that answers your question. But there's a lot of new projects coming out. The cool thing about crypto is that it's inherently open for everyone to go ahead and do that. And the developer cannot try to hide their coin or how they issue the coin. So that's really cool.
All right, so as one of those evil game developers that loves to take advantage of people economically, one of the issues with mobile gaming, microtransactions, is going through the Apple Store or Google Play and being forced to A, use their payment channels, and B, pay them a hefty 30% cut for anything that you sell. How realistic is it to, unless you're using like Status or Cipher or Toshi to, basically doing big, like a web app. Can you really create a game in the app stores that can use microtransactions through the blockchain and somehow get around those legacy payment systems? It seems like if you want an app, you got to pay the piper, you got to pay the app store to facilitate that transaction.
Okay, yeah, that's a really good question because when you are using CryptoKitties, you're going through MetaMask or Mist, and you're going through a node that you're trusting in a sophisticated way, but you're trusting anyway. So I think that there's two parts of the problem. The first part is how do you incorporate a thin client for a microtransaction channel, because you don't want to have a blockchain on your phone. And this is something that is a big challenge to date. The way that games that work with crypto right now is that they have trusted nodes. So it's not like, there's still that part missing. And I think I'd really like to see a mobile app that is for payment channels that can be a companion to another mobile app that you can use to accept the payment. The other part of the problem is, will Apple and Google like it? Because they are happy with their 30%. And that 30% is probably more than the fee that you're going to pay to the Lightning Network or payment channel. So these are hard problems that we need the community to solve. And we as a company are super, we will do anything that we can to help tackle these problems. But you are right that these big problems.
So I have a quick comment and then a question about the microtransactions or the payment channels. So the first was just on the first question about like game companies manipulating the currency, the in-game currencies. This wasn't so much about manipulation, but there was a really interesting interview or podcast episode of Unchained where I think it was the founder of MakerDAO and then the founder of Second Life were talking about stablecoins. And so that was a really interesting, so you're not just, when you're talking about games, I thought it was interesting, I never really thought about it. When you're talking about money in games, it's not just the payment and then the sort of out-of-game transacting of it, but also how do you control the supply, and then you can change the supply. This can even happen with blockchains, right? You can actually build into the blockchain how much supply goes in and out of the game, and that's actually what they were talking about. So that was an interesting discussion. The question is with the payment channels, we were talking about how to deal with a bad actor. You basically have that hold period of 2 days or whatever it is, and you have then the other party has that amount of time to dispute that. What happens if, let's say, I'm on holiday and I'm not keeping track of my payment channels, and if there's been something that I need to dispute? How are those typically handled, and how do you deal with that in the business that you're building as well?
Yeah, so the way you handle that, the more common scenario is it's a DOS. So basically, if you can stop somebody from checking the blockchain for 2 days or whatever the whole period is, then you can do whatever you want. So the way you deal with that is with bounty hunters. And how a bounty hunter works is that you send you create a transaction that says, the person who submits this transaction, if this transaction, so basically what it says is the channel, if the channel is being closed, and this transaction has a higher sequence number than the transaction that is closing the channel, then the person who submitted this to the blockchain will get this reward. And that reward could come out of the channel itself, or could be attached to the channel, or it could come out of the person's account or whatever. But what you do then is you can send it to some servers which are set up to check the blockchain, all the time. And try to try to stop channels from being closed with old transactions with a low sequence number. And so, if the first bounty hunter, that's sort of what we call a bounty hunter, the first bounty hunter which is able to do that gets that reward because they stop the channel from being closed with an old transaction. And so that's also how we deal with that in Althea too. Our channel contract has that capability built in for a bounty hunter to do that.
Just a point of information. In the Lightning World, bounty hunters are called watchtowers.
I just want a point of information is that in Lightning, bounty hunters are called watchtowers.
Oh, cool. Yeah, I'm not too familiar with Lightning, unfortunately. I work with Ethereum, so yeah.
Hey, I just wanted to comment. It seems, and I'm not familiar with the problem, so I don't understand, whether it's been documented that the games have actually cheated players for rare items that they've sold. But it would seem that a logical solution would be to utilize side chains. So issue a coin, transact in crypto in exchange for the coin, and then utilize side channels or side chains to aggregate payments, and then reconcile maybe at the end of the day or in some timing, some time fashion, because it just doesn't seem feasible to process all those transactions real time. And I'm curious whether you've had any experience with that model or have given it any thought.
Oh, well, when we start using Lightning in a game, opening channels, we can open a network of channels. So we can do. I'm not very familiar with side chains, but we can do more or less the same using Lightning Network by only settling on the blockchain. And there's a feature in the Bitcoin Core actually that is called Move. So you can make many accounts inside one node and move between those accounts as a debit credit system inside the same node. So if you don't like if you are fine without having cryptographically correct in every step, you can even do without side chains. You can do internal ledgers, and so that means that there's more than one solution to solve the problem. But I agree with you that there's a need to do a lot more transactions that are not that are for games. That we don't need that information on the blockchain, and there have to be more than one method to it. The way we are doing it is using the Lightning Network, and we can only do a Bitcoin transaction when a player cashes out the game.
I'll also add that you can think of a payment channel as being a side chain. I mean, this is kind of a loose analogy, but it's a side chain with like two miners. So obviously, doing a side chain with more things going on and not just payments and a lot of people participating is going to be a lot more complicated. But it's a similar concept to payment channels.
We can take 2 more questions this evening.
Hi. My question, so let's start with the situation. We have a cool game, you just started it, you have a lot of users, and you create some rules. And then someone inside the game that's playing the game is gaming your rules, and somehow is destroying the whole feel of playing for all the users. Nowadays, you as a developer can come in and say, we don't defraud our users, but we just recreate the game more engaging. We change a bit the rules, subtle. How do you do this if you have a contract for those rules? And if you are able to change that contract, why would I, as a player, give value to your token in the beginning, or to that rare item, if I know that even if you have a contract, you will change the rules if something happens?
Okay, in a new game, Dark Winds, it is a card game, collectible with crypto collectibles. We are calling the first million cards first edition cards. So it's like a season. So there's a season that we all play, then the season ends, and the next season we will get a new contract with different rules. And if we need to change them, we will change them. Otherwise, we will start a new season with the same rules. We also have a hard cap on how many first edition cards you can get on a million. So to have transparency with the users, we can tell them that there's only going to be, I think the rarest card is 12,000. So there's only going to be 12,000 first edition cards of that same model. But yeah, the way we are doing it is, I know there's smart contracts that can be upgradable. We choose not to, just to make things more entertaining and to make a point. But we're making it in seasons, so we call it first edition contract, and it lasts. I mean, it lasts forever. People will still want to play first edition, but when second edition come out, we hope that it's a better contract and people will move to the second one and start all over again. But yeah, that's how we do it, and I'm pretty sure there's more ideas to that.
So I have a high-level question for you guys. You've clearly been great talks, by the way. Thank you for taking the time to explain some technical stuff that's hard to understand. You've clearly been looking at this stuff for a long time and thought about it a lot. When I think about the notion of payment channels and side chains and other things, it sort of indicates to me that the standard way that Ethereum and Bitcoin are operating needs a little bit of Band-Aid fix. Do you guys think that this is sort of a long-term solution to all this, or is there going to be a real fix that doesn't sort of makes all this stuff, this Band-Aid go away at some point in time?
I think that payment channels are useful even for conventional payment processors if they need to be able to handle a lot of payments very quickly between devices that don't trust each other. They have a lot of applicability to blockchains because blockchains are slow. I think that any system, like a lot of the scaling solutions that people are doing do involve mechanisms like this. Obviously nothing is working in production yet. I mean, I think there's some projects that are lesser known that are working, but it's it's still early days. But I think that scaling blockchains will rely on this kind of concept, because you can, I don't get into the Bitcoin drama and stuff, but you can increase the block size, but it still remains that everybody, if you have a chain, it's a global chain, everyone's using it for everything. Every miner on that chain needs to know about everything that's happening on the chain, and that's just not sustainable. So I'll take an analogy from the internet, which I work with a lot. On the internet, you don't know if somebody's phone has moved in China. If you want to send them a message, you don't need to know where their phone is located in China or if they moved to the cell phone tower, because you have subnets, and you just know that there's a subnet, and you got to send to that, and from there it knows how to get routed to that phone. And so I think maybe that's not a great analogy. I mean, it's a little bit different, but I think with blockchains you need something that's a lot like that, where you can kind of compartmentalize a lot of things into their own separate spaces, so that everybody in the world doesn't need to know about the fact that you just bought a rare hammer in your video game or whatever it is. And that's what these payment channels let you do, and side chains and stuff, is that you can have a trustless way to keep a whole swath of transactions private, and also not having to burden everyone else with those transactions, because you can resolve them.
So when you build a game, normally you do like beta testing with users, and a lot of times in the beginning you try to like balance off features, because like sometimes one character might be like too strong for like the rest of the players. But if everything is immutable, like even if you do this like season-based thing,
even if you do like season-based upgrade kind of mechanism, like, because how do you handle that?
The question is, if we have to balance a game and beta test it, that will be really difficult if we have immutable rules, right?
Yeah.
Okay. Okay, so the way we are doing it now with that Windsor new game is that we open 5 months beta and we'll balance the game and then we will compile everything into the rules, the official rules. Well, there's also the season thing that rules are only applying for a season, like in a sport. But I think there's the other problem too. I mean, the problem that did you know that Vitalik Buterin thought of Ethereum by playing World of Warcraft because they changed his most precious item or something like that? I think you can look it up. I think that's so. There's also dangers on the developers who can abuse the rules and use asymmetric information. So I think there's no ideal solution to a problem. I think we're on the other side, the side of the clear rules, immutable things, but that also takes time. So in the fast world of software, trying to get the game right means a few weeks of beta testing. Maybe we should try to be more conventional and try to wait a few months before changing the game or creating the opportunities to change it gradually in time. I think that's the way we see it. And also, did you know that for a lot of time in basketball, there was no three-pointer. Like there was only 2 points. People realized that created a very big advantage for the tallest player. So that then they created the three-pointer. So a shorter player that has skill can also win the game. That was probably very difficult to change basketball, but there's no mutability in basketball. It has changed. So I think maybe we need a little more patience. This is a different type of making games that involves more time, and I think having players on the loop, making them have all the information that we're testing and stuff, we can make it right. But yeah, it's slower and more difficult.
Well, thank you. I think we have our next month's topic, immutability of basketball. But that'll do it for the Q&A section for now. And give a big round of applause, please, for our speakers. I know Christian Bihar might be sticking around for a little bit if you guys have any further questions. There's still some more drinks. We got the place for another half hour, 40 minutes or so. So please, hang out, socialize, and thank you so much for coming out tonight.
Oh, yeah.
It's one of my
Hello. Oh, sorry. Here's my card. Do you have a card?
No, I don't.
I'd love to get a copy of your presentation.
Okay.
If that's possible.
The one I just gave?
Yeah.
I think they have a live stream, so you could should ask Travis about that. He's the organizer, yeah.
It's on YouTube. If you go to the main page, in fact, the video's still running. I'm going to stop it right now.
Oh, wow. Yeah. Yeah, I'll download it. Travis.
Okay, all right. Thank you very much.